Assalamualaikum and good afternoon to our Miss Soleha. So today, me and my groupmates are going to present about application of differentiation. So first of all, let's meet our group. The first member is Muhammad Hakimi. Second is me, Muhammad Irfan MIRZA, and the third one is Muhammad AFIQ ZIKRI. So what is differentiation? Differentiation is a method used to compute the rate of change of a function, or we call it fx, with respect to its input x. The rate of change is known as the derivative of x of f with respect to x. The formula is fx equals to dy over dx. So in application of differentiation, we have 6 subtopics in it. The first one is related rates. Second one is intervals of increasing and decreasing, or we call it concavity. The third one is first and second derivative test. The fourth one is graph of polynomial function. The fifth one is maximum and minimum values. And the sixth one is Rolle's theorem, mean and value theorem. So for this presentation, we decided to choose intervals of increasing and decreasing and graphs of polynomial function. So let's talk about the subtopic that we choose. In calculus, the intervals of increasing and decreasing refer to as the intervals where a function is increasing or decreasing as its input variable changes. These intervals can be found by analyzing the function's derivative. Some of you may ask, why do we need to learn this? So the first thing first is, the intervals of increasing and decreasing can help us to understand how a function behaves as its input variable changes. This can be helpful for understanding the function's graph. The second one is, the intervals of increasing and decreasing can be used to help us graph functions. This is because the intervals of the increasing and decreasing correspond to the intervals where the function's graph is rising or falling. The third one is, the intervals of increasing and decreasing can be used to help us to solve some problems by identifying the intervals where the function is increasing or decreasing. Next, I will pass it to my next member, Kimi, to present about the problem statement and the solution.
Assalamualaikum warahmatullahi wabarakatuh. So I will continue with the function that we choose. So from this question, first we must find x-intercept and y-intercept. Second, find interval increasing and decreasing. So from this function also, we must find extremum if any. Third, find interval is concave up and concave down. So we must find inflection point if any too. Lastly, sketch the graph. Okay, we go to the first question. So we must find x-intercept and y-intercept. So for x-intercept, y will be 0. So we just need to substitute the y with 0. So we can just get the values of x to the calculator. So here we have 3 values, negative 3.25, 1.91, and negative 0.16. So for y-intercept, x will be 0. So for this, we just need to substitute x with 0. So we get negative 2. Okay, we go to the second question. So for this question, actually we must differentiate the function first. So after differentiate, we have 6x squared plus 6x minus 12 equal to 0. So the critical values we get from this function is negative 2 and 1. So how we can get critical point? So we just need to substitute the critical values into the function. So here we have 2 critical point, negative 2 and 18, 1 and negative 9. So next we go how to find increasing and decreasing. So here we must test it. So we can look at the table. First interval, we have 3 interval and we have 3 test value too. So the test value we get from the interval. So the result is we get is positive, negative, positive. So the conclusion is fs decreasing in the interval negative 2, 1, and fs increasing in the interval negative infinity until negative 2, 1 until infinity. Next, we must to find maximum point and minimum point. So here, first we look for -2 first. So here we have a 2 interval for -2, negative infinity until -2, -2 until infinity. So latest value we get from the interval. So the result is positive and negative. So if the result is positive and negative, the point will be maximum point. So here -2 and 18 is a maximum point. So next for 1, here we have a 2 interval 2. So negative infinity and 1 until infinity. So the test value also we get from this interval. So the result is negative and positive. So if the result is positive and negative and positive, so the conclusion is the point is minimum point. So here 1 and -9 is minimum point.
Next, we want to find the interval where f is concave up and concave down and determine the inflection point. So first thing first, what we need to do, we have to find the second derivative of fx. How to find the second derivative? We just do a differentiation to the first derivative, which is 6x square plus 6x minus 12. After the differentiation have done, we got 12x plus 6. And after the calculation have done, we got x equal to -1/2. Next, we do a test value. So at the negative infinity to -1/2, the sign of the f second derivative is negative, which is the concave down. And the next one is -1/2 to infinity. We got positive, which is concave up. So next, we want to find the inflection point. The inflection point, we have to know the inflection value. So the inflection value is equal to x. So it equal to -1/2. And how to find the inflection point? We just have to substitute the inflection point into the inflection value into the original equation, which is 2x cubed plus 3x square minus 12x minus 2. So after the calculation have done, we got inflection point -1/2 and 9/2. And next, we want to sketch the graph of f. So how to sketch the graph? We just have to mark every point, every information that we have calculated before. So what we have the maximum point, minimum point, x-intercept and y-intercept, and also the inflection point. So it's going to be somewhere around here. So after we mark every information that we have, we just need to connect every point. So we got this. Yeah. For the summary, a function is increasing on an interval if its derivative is positive on that interval, and a function is decreasing on an interval if its derivative is negative on that interval. The interval of increasing and decreasing can be used to understand the behavior of a function, graph a function, and solve optimization problem. And the conclusion from this topic is that the interval of increasing and decreasing are important concepts in calculus that can be used to understand the behavior of function, graph function, and solve optimization problem. By understanding this interval, we can better understand the behavior of function and use this knowledge to solve problem. And that's all from us. Thank you.